Hi, everybody. This is Mr. Corzine. I'm going to finish these notes, lesson 4.4. We're studying slope and rate of change. Now, slope and rate of change, they're pretty much just the same thing. I'm going to try and talk you through that, help you understand like how to solve problems, how to find the slope, given just a little bit of information, and to compare it with the rate of change. Now, the first thing I want to do is just give you some basics on you know, on slope. So if I have a line going uphill like this on my coordinate plane, up means it's going to have a positive slope. And if I have a line going downhill like this, going down from left to right, then it's going to have a negative slope. So that's just like a quick, easy way to refer to the slope of a line and to describe it really quick. If we want to describe it more clearly, then slope is described as the rise over the run. Okay, so as I look at this point right here and I go to this point here, I'm going to have to go up. How many? I go up 3, that's a positive 3. So I rise 3. And then I run, or I go over in the positive direction 5. So I run 5, that's a positive 5. So my slope is 3 over 5. Slope is represented by the letter m. I'm not even sure why that is, but m is going to equal, in this case, 3 over 5, or we could say 0.6. Any of those will work just fine. On the next one, we have the same thing, only you'll notice that the line is going downhill, like so. It's going downhill, we know it's going to be negative. So the rise over run that we end up with should have a negative value. So here, rise over run is going to equal, I'm going down 8, so that's a negative 8, and I go over in a positive direction, 6. That means that when I simplify, I divide by 2, I end up with a negative 4 over 3. That is my slope, and it's a negative slope. That's about it, guys. Like, I could have gone backwards, and if I did, I'll change colors here and show you how it would still work out just fine. If I started here and went to in the other direction, I would go backwards 6 and up 8. So my rise over run, in this case, backwards 6, up 8, that means I would have a positive 8 but a negative 6. Guess what? My fraction would still be a negative 4/3. Either way, it doesn't matter which direction I go. From right to left or left to right, I'm still going to end up with the correct slope. If we go on to the next one, I want to introduce you to the slope formula. Slope formula is pretty simple. It is the change in y over the change in x. Now I'm going to make a little note down here about what this change, this triangle right here, this triangle is called delta. It's a symbol called delta, and it represents change. How will I find the change? Well, the formula looks like so. I'm going to take y2 and y1. I subtract them to find the change up here. And then I take x2 minus x1, and that is my slope formula. That might not make a lot of sense right now, but we'll scroll down and we'll do a couple of examples here, and this should make sense. When I look down here at the bottom, I've got 2 points. Now on those points, it's on the coordinate plane. I'll put it on here. I got a negative 4 and a negative 1, and look right here. 5, 9, it would be right here, and I've got this line going up and down like that. I don't know, that's not exactly what it'll be. I'd have to measure it out, but I've got a line that looks like it's going to be going up and down. It's going to be positive. Now, I could graph it on there and count out all of my spots and find out what the rise over the run is, or mathematically, I could do some quick work and be done quicker. So I'm going to label these. Here's my first point. We'll call this point number 1. So each one of the points, each one of my values is going to have the subscript 1, x1, y1. My second point has an x and y value, but that's going to be x2 and y2. Well, now I use my formula. I scroll back up, I see y2 minus y1 over x2 minus x1. So this isn't y squared. This is my second y value minus my first y value over my second x value minus my first x value. Let me plug in those numbers now, and I'll change colors so it makes it a little easier. Y2 is right here. That's my 9. And I'm going to subtract whatever y1 is. Y1 is a -1. So see how I got a double negative happening here? On the bottom, x2 minus x1. So I take my x2 value, which is 5. Now I'm going to subtract my xy value, x1 value, which is a -4. Again, I'm subtracting either a positive or a negative number. I got to keep track of all that. 9 minus a -1 is really like 9 plus 1, so that makes 10. 5 minus a -4 is really like 5 plus 4, and that makes 9. My slope in this case is 10 over 9, and I don't need to simplify it any different than that. I don't need to go any further than that. We'll try it again over here for number 2, x1, y1. It's really helpful to label these guys, so go ahead and do that. x2 and y2. Now, change my colors again. We'll try green this time. I'm going to plug in my numbers. I'm going to do y2 minus y1 over x2 minus x1. What is my y2 value? It's 8. And I'm going to subtract my y1 value, which is 5. x2 minus x1, I'm going to put my subtraction sign in there right away. x2 is -7. x1 is a -2. When I get done subtracting, 8 minus 5 is 3. -7 minus a -2, that's really like -7 plus 2. That makes a -5. So my slope is a -3/5. Well, now I want to find the missing value, and this might be the most challenging problem that you have in all of this section. We've got my end slope. I know what the slope's going to be. I have 2 points, and I'm just missing one value right there. Well, let's label them x1, y1, x2, y2. If I wanted to find the difference between the x values and the y values, I could find the slope, the rise over the run. Let's use our formula, y2 minus y1 over x2 minus x1. I plug in my values. And what do I get? y2 is 1. And I will subtract y1, which is y. Whatever that is, I don't know what it is, it's y. On the bottom, x2 is a -2, and I'm going to subtract 0. Great. In the end, after I evaluate this a little bit, I get 1 minus y equals -2 minus 0, which is basically -2. All of this is supposed to be equal to a -8. So I'll make it into a fraction, -8 over 1. Now, at this point, you might be stuck. You might be thinking, well, that's as far as I can go, and now I might just have to guess and check until I find something that makes a fraction equal to this fraction. Well, I guess you could, but the other thing to remember is that you can use your cross products. I can multiply these two. These are like 2 equivalent ratios. So I've got 1 minus y times 1. Well, that's really just 1 minus y. And that's going to be equal to a -2 times a -8, which makes 16. Now, ladies and gentlemen, we have a very simple equation. Change here. Let's do this. You know, I can subtract 1 on both sides and get rid of this. And now I have a -y equals 15. Then what? Well, I've got a -y, so I, here we go, divide by a -1 on both sides. And what does y equal? Y equals 15. I'm sorry, -15. Ta-da. That's not bad after all. Now, if I go back and I plug this in, what's 1 minus 15? What's 1 minus a -15? Well, it's like 1 plus 15, which makes 16. 16 over a negative 2 is going to make a negative 8. Now we got to find the slope of this line. This line right here is a horizontal line. Horizontal lines do not rise. So the rise over the run is like always going to be 0 over, in this case, 1, 2, 3, 4, 5, 6. It ran 6, but it didn't rise at all. Well, what's the slope? 0. Okay, that's it. It's like, hey, what was the slope of that hill that you just walked? You mean that flat ground? The slope was nothing, okay? If it was less than nothing, then it would be like a downhill slope and there would be something to it. But if it's flat, there is no slope. However, if you're going to climb a cliff like this, straight up and down, that's different. A vertical line is different. It climbs forever. It goes up. This one goes 1, 2, 3, 4, 5, 6, 7. The rise over run, in this case, it's going to be, well, it'll be 7 over, there is no run. It's 0. Now, whenever you have a fraction like this and you're dividing by 0, it's really impossible to do that. And that's why we don't call it 0. We call it undefined. Whenever you try and divide by a 0, it's not really possible. So it's undefined. It's not possible. Here's the last slide that I'm going to do with you. This deals with the rate of change. Rate of change and the slope are the same. Same thing. The only thing that's different is that a rate of change has units with it. Okay, so in this case, I'm going to look and I'm going to see how it is changing. Look how the hours are changing. From 2 to 6, I go up by 4. As the time is changing, the gallons are changing. What is it going up by? It's going up by 9. And for this table, it's going up consistently. Every time 4 hours goes by, we get 9 gallons evaporated. Well, let's look at this. The rate of change is the change in y over the change in x. That means I'm going to look at the change in gallons. That's 9 gallons over 4 hours. And if I simplify that down, I get 2.25 gallons per hour. Rate of change and slope are exactly the same.